In the final lesson in this module, I'm going to go over the solution to Euler's problem number 2 from the previous lesson. So to solve this problem, we need to generate the Fibonacci sequence terms that do not exceed 1 million. We need to identify the even valued terms in this sequence, and we need to calculate the sum of these even valued terms. So here's a program to achieve this. So I have it open here. So we define a function called sum of even Fibonacci. It accepts this parameter or argument called, so we're going to use the variable limit. And so we're going to start by assigning the values 1 and 2 to variables a and b. Okay, so we know that the Fibonacci sequence starts like that generally, right? So it's 1, 2, and then we add 1 and 2 together to get 3, and then 2 and 3 together to get 5, and so on. So the running sum, or total sum, is equal to 0 initially. It's set equal to 0. And here we are going to use a while loop. So while a is less than or equal to the limit, now in this case the limit is set to 1 million. Okay. So while a is less than or equal to 1 million, if when a is divided by 2, if we get a remainder of 0, so it's equivalent to, so this is equivalent to 0, then we are going to add a to the running sum or total sum. Okay, and then what's going to happen here is that in terms of what's going to happen to a, so a is now going to have the value of b. Okay, so it's now going to store the value of b, and then b is going to store the value of a plus b. So we move to the next pair of Fibonacci numbers. Okay, and so then this is going to repeat now. Okay, and now a here is actually has the value of b, which initially is 2. Okay, and then so the loop will execute again. It will repeat. And so 2 divided by 2 does give a remainder of 0. And so we're going to add 2 to the running sum. Now, in terms of what a is going to be assigned, is going to have the value of, so originally had the value of 1, right? But now b in this case, okay, was assigned the value of a plus b, right? So it's now actually 3 now, right? So a is now going to have the value 3, okay, stored in it. So then this loop will repeat, and now it's going to be 3 here now. And 3 is less than or equal to 1 million, right? So this will execute. So 3 is not divisible by 2, right? The remainder is not going to be 0. So 3 is not going to be added to the running sum in this case. Okay, and so then this is just going to keep on going. And a and b will have like increasing values, and in terms of the values that they will have, they'll just have the values in the Fibonacci sequence. So then eventually a will become 3 plus 5, so 8. Okay, it'll have the value 8. Okay, and then so on. Okay, so it'll be 5 and then 8. Okay. Now 8, when it is divided by 2, the remainder is 0, so that means that 8 will be added to the running sum. Finally, once we get to a point where A is actually a million, okay, once A is a million, or a value greater than a million, then this will not execute. Okay, so these lines of code will not execute, and the total sum, whatever is stored in the total sum, whatever number is stored, is going to be returned. Here we have the result, so we have a result variable, and we're just we're assigning whatever is returned by the sum of even Fibonacci numbers, the function here. And then finally we are going to print out the result, and we use f here just so that we can input the actual values here. So the limit, which is a million, and then the result, whatever value is stored in the result. So the sum of the even value Fibonacci terms not exceeding a million is whatever is calculated. So let's run this and see how it works. And so we get, so the sum of the even valued Fibonacci terms not exceeding a million is this number here. So 1,089,154. Okay, and so that brings us to the end of this module and the end of this lesson. Thank you for watching the videos in this module.